Hey everybody, Mr. Qualls. I'm going to talk to you about, and I tried to put this up a little, there we go. I'm going to talk to you today about what happens when a transversal cuts two parallel lines and what the relationships between the angles that we've created with that transversal, what we can do with those to solve other problems. So the goal of this the goal of this whole thing is this over here. I'm just going to take my computer over here for a second and show you this. So what we're looking at is we want to use informal arguments to establish facts about the angles that are created when parallel lines are cut by a transversal. Now the word cut, the kids in my class would rather say crossed or intersected, but we use crossed. So when a transversal crosses two parallel lines, and we're talking about finding facts about the angles and informal arguments. So we're not proving things. We're just saying, hey, this makes sense because we know these things are supplementary. Two angles that are together, 180, are supplementary. So let's take that idea and build from that. Now, my last video, what we did was we established that 1 and 2 are supplementary angles. And because they're supplementary angles, what that means is that the angles, the measure of angle 1 and the measure of angle 2, don't like that marker. So we're going to change markers here. The measure of angle 1 plus the measure of angle 2 equals 180 degrees. And if it equals 180 degrees, what that does is establishes a couple of things. And we talked about vertical angles as well in the last video that I made. And that is what the 180 supplementary idea helped us with in that video, is that if 1 and 2 are supplementary and they're different angles, that's why I mark one of them with 1 stripe and the second one with 2, is because if this and this angle are supplementary, that means that they sum to 180 degrees. Now, if we take this away from that idea, 1 and 3 are also supplementary together. That means that 3 is equal to angle 2. 4 is equal to angle 1, 1 and 5. So we have these ideas that angles across from each other, or vertical angles, are equal to each other or congruent, and 1 and 4 are also congruent. 5 and 8 are congruent, and 6 and 7 are congruent as well. The idea that we can take the idea or the relationships from this intersection into this intersection is with the transversal. And we talked about how trans means to move from one place to another, or to transport, or transpose, or translate, or transcontinental something. It means we're going from one place to another, and we're taking these relationships into this intersection down here. So if 3 and 2, or excuse me, measure of angle 2 and the measure of angle 3 are congruent, that means something else down here as well. And what it really gets to is that 2 and 6 are congruent, because the transversal comes down through here and hits this at a certain angle, and it also hits this group at the same angle when it comes down. That means that 2 and 6 are congruent. That also means that 1 and 5 are congruent, and 8 and 4 are congruent, and 3 and 7 are congruent. These angles are referred to as corresponding, and the reason they call them corresponding is because they correspond to the same location in the other intersection. For instance, angle number 1 corresponds to number 5 because it's in the upper left of this intersection, and 5 is in the upper left of this intersection. 2 is in the upper right, So it corresponds to 6 because it's in the upper right, 8 and 4, 3 and 7. Now, if you look at this, the relationship that the transversal takes from here into this, here's what this does for us. It means if we know that 2 is 70 degrees, just made that up, but it's an acute angle. You can see that it's less than 90, it's acute. If that is 70 degrees, that means that this is 70 degrees as well, because corresponding angles are congruent. Corresponding angles are congruent to each other. All right? And corresponding angles here would be 1 and 5, 2 and 6, 3 and 7, and 4 and 8. I'm going to erase these real quick. Here we go. So if I wanted to list all my corresponding angles would be angle 1 and angle 5. And what do I know about them? They are congruent because they are corresponding angles. Number 2, measure of angle 2. That's not 2, that's a 1. 2 is congruent to the measure of angle 6 because they're corresponding angles, and corresponding angles are congruent to each other. The measure of angle 3 is congruent to the measure of angle 7, and the measure of angle 4 is congruent to angle 8 because they are corresponding angles, and corresponding angles are congruent to each other. They are congruent to each other. We're going to use that later in an argument to solve a problem because they're congruent to each other, and we can use that to our advantage. So let's look at the next thing. The next piece here is alternate interior angles. So what I'm going to do is I'm going to mark this as the interior. And I'm going to mark this as the exterior. And this section as the exterior. Whoa, that's a fancy O. So, exterior. Now, what I mean by interior is inside the parallel lines. Exterior is outside the parallel lines. And this, the transversal, and then what we're going to do is look at alternate sides of the transversal. So we're going to go one side and then the other. Just like if you were going to walk down, you're going to alternate your feet when you walk down the hallway. I hope that's the way you walk. Left foot, right foot, left foot, right foot. The other night, my wife and I giving out Halloween candy at the door. Didn't have a lot of trick-or-treaters because of COVID, but we still alternated handed candy out. So I took the first group, she took the second, she took the fourth. So we alternated one and then the other, one and then the other. Okay. So when we talk about alternate interior angles, we're going to alternate and they're interior. So here's what we're looking at. We're looking at alternate sides of the transversal and we're looking at interior angles. Well, so we're looking at these two angles, alternate interior angles. So we're looking at angle 3 and angle 6. Now, what do we know about angle 3 and angle 6? How are they related? Well, I know that angle 3 was congruent to angle 2 through the idea of vertical angles that we talked about in the last video. So I know that this and this are congruent, and I know that this and this are congruent because they are corresponding angles which are congruent. So this is like having, let's say, you and your your brother and your sister. Okay? So your brother and your sister have the same amount of money. We don't know how much it is, but your brother and your sister have the same amount of money, and that money is going to be X dollars, okay? These two have the same amount of money, and then you and your sister, let's go this way, you and your brother also have the same amount of money. Your brother and you have the same amount of money, and your brother and your sister have the same amount of money. How does that say, what does that say about you and your sister as far as how much money you guys have? The same amount. So this idea is called the transitive property, where you have equal over here and he has equal to her. That means that you and her are also equal to each other. Oh, I should have used the same amount of candy from Halloween instead of money, but I don't know if everybody got candy. So, but here's how we do this. How do we get this idea and this idea together? Well, 6 is congruent to 2 through corresponding angles, and 3 is congruent to 2 because of vertical angles. That means that 3 and 6 are congruent also. And 3 and 6 are alternate interior angles, which means alternate interior angles must be congruent to each other. That's pretty sweet. So, which ones of those are alternate interior? Well, angle 3 and angle 6 are alternate interior, and they are congruent to each other. Is there another angle group up there, pair up there, that is also alternate interior? That's right, 4 and 5. So 4 and 5 are also congruent to each other. They're also congruent. So now I have corresponding angles are congruent. Now I have alternate interior angles are congruent. I wonder if alternate exterior angles are also congruent. Well, let's check it out. Check it out. If we look at 1 and 8, and we're talking about alternate exterior angles, what do we know about 1 and 8? Well, I don't know anything about 1 and 8, but I do know that 1 is congruent to 4 because they're vertical angles, and vertical angles are congruent to each other. 4 and 8 are also congruent because they are corresponding angles, and corresponding angles are congruent to each other. So that means we've used the transitive property again. 1 and 4 are congruent, 4 and 8 are congruent, therefore 1 and 8 are congruent. And since 1 and 8 are alternate exterior angles, that means alternate exterior angles are also congruent. So my alternate exterior angles are the measure of angle 1 is congruent, the measure of angle 8, and you know what I'm talking about next. Is there another pair of alternate exteriors? That's right. It's right here. 2 and 7. Measure of angle 2 whoop, whoop, is congruent to angle 7. That's the weirdest thing. Oh, now I'm going to use the eraser rag instead of my filthy fingers. There we go. Oh, now I'm starting to obsess over things. I just got to stop. So, look at what we've got now. We have different arguments to argue over different relationships, and they're just informal. I made a bunch of informal arguments to establish facts about the angles and the relationships to each other that are created when a transversal cuts through two parallel lines. There's nothing up there that isn't related to another angle in multiple ways. So I'm going to erase this. And then we're going to do a couple of problems. Oh, sorry. Same side interior. Well, if we're talking same side, not alternate, but same side, okay? So we're talking about 4 and 6 maybe. What are we going to do about 4 and 6? Well, do we know anything? Do we suspect anything? There's only 2 measurements up here. 2, 3, and 6 and 7 are all the one measurement that's acute. And then there's an obtuse angle that makes up the 180 that makes it supplementary. And that's the 1, the 4, the 5, and the 8. Nothing else. So 4 and 8, or excuse me, 4 and 6. 6 is the acute one, and 4 is the obtuse one. So if the obtuse and the acute combine in this case to be 180, what's that say about 4 and 6? Think about this. 6 and 2 are congruent. 6 and 2 are congruent because of corresponding angles. 4 is the thing that makes 2 into 180. So wouldn't it make 6 into 180? So I think what that means is that same side interior angles total to 180. So if we have the 2 of them, their sum equals 180. That's going to help us solve a couple of problems here in just a minute, because the main thing that we do is we concentrate on, are these 2 angles equal to each other or are they supplementary? And if they're supplementary, they combine to be 180. And if they're not, they're equal to each other. And if they're equal to each other and we know one of them, we know the other. And if not, and they total to 180, then what we can do is make an equation that shows, hey, this is what 180 looks like. All right, or these 2 angles equal 180, and then we can just solve our equation. Cool. All right. So here's there's a couple of questions here that are in the book, and I'm going to take them. They're right off of page 349. So I'm on page 349. Page 349. And example 1A says, find the measure of angle 2 when we know that the measure of angle 7 is 125. That doesn't make any sense. So let's change the question a little bit. I'm going to say, let's find the angle 1 when angle 8 is 125. It's 125 degrees. Okay. So what we want to do is we want to decide. There's only 2 real things that we're going to be talking about here. Are 1 and 8 equal to each other, or are they supplementary and they total to 180? Well, what kind of relationship do 1 and 8 have? What kind of relationship does 1 and 8 have? They're exterior and they're alternate. Hey, they're alternate and they're exterior, so they are alternate exterior angles. So if they're alternate exterior angles, that means they're congruent. And if 125 is the measure of angle 8, that means angle 1 is also 125 degrees. All right. That was pretty simple. This next one, though, it's a mind breaker. All right. So what we're going to do here is we're going to put angle, oh my gosh, we are going to say that this angle right here is 6x, and this one equals 3x. So what do we know about angles 3 and 4? Do they have a relationship? Have we made a formal argument that has established the facts about the angles created when a parallel lines are cut by a transversal? Do we know a relationship between 4 and 6? Are they corresponding? Are they alternate interior? Are they alternate exterior? Or are they same side interior angles? Yeah, they're same side and they're interior. So same side interior angles, that means the 2 of them together make 180 degrees. So what I'm going to do is this, and we don't have a lot of experience with this yet, so watch. I know that if those 2 are put together, They total to be 180. So all I'm going to do is say that 3x's plus 6x's equals 180 degrees. Now, a lot of people that are still concrete thinkers will tell me that there are 2 x's on the board right now, and there aren't. There's 3 x's over here, and there's 6 x's right there. So how many x's do I have over here? Wouldn't it be nice if I had them all together? So what we're doing is we're going to combine like terms. We're going to combine, which means put together, like terms. Like terms. And I know you haven't seen that too many times, but if this is an x and that's an x, they're x's. Put them together, right? One of the things that I like to do is keep my x's separated as far as I can. It's always dangerous to have 2 x's in the same room. But that's not what we're talking about. We're not talking about that. We're talking about math here. Try to focus, would you? Come on. So 3x and 6x. 9x is over here. 9x. That's a lot of x's. Equals 180. This is now a one-step equation that every single person in this building knows how to solve. Every single person knows how to solve a one-step equation. And I know it's true. So how am I going to do this? Well, something times 9 equals 180. So I'm going to divide this side by 9, divide the other side by 9 as well. So I'm dividing both sides of the equation by 9. 9 over 9 is 1. 9 over 9 is 1. 1x, here I am, and 180 divided by 9. 18 divided by 9 is 2. With the 0 is 20. Now, a lot of people think we're finished now, but we're not. We solve for x. How much farther could this possibly go? Well, I'll tell you how far. Because we're looking for 3x. We're not looking for x. We're looking for 3x because we want to know what the measure of these two angles are. And 3x means 3 times x. So x is 20. That means this angle right here is 60 degrees. And it's acute. Yep, think it's working. 20 times 6 is 120 degrees. Now, we should check to see if we kind of have what we think we should for answers now. Now, what were we expecting? Were we expecting that 4 and 6 together made 180 degrees? That is what the idea that we were using to make the whole argument of how to set up this problem. So they should equal 180 after we're done. So let's just check it. 60 plus 120 is 180. Super. Okay? Looks like everything's rolling for us. All right? Let me check to see if I have anything else that I should be doing here. Oh. We should look at page 350. That's right, 350. We're going to look at page 350. And we've got, this time what we're going to do is we're going to put 4x over here. That's a lovely song. You should record it. 4x and 6x is over here. And let's get rid of this other garbage. What do we want to know? Well, we want to know 3 things. We want to know 3 things. We want to know the measure. We want to know this angle right here. We want to know this angle. We want to know this angle. And then we want to know ouch, that one. And then we want to know, whoa. Let me look at this just a second. CDG, I want to know that one. This one's like, yep, I want to know this angle up here. Why not? So here's my argument. One of the arguments I'm going to use. If I find out what these are, I don't have to calculate that one afterwards. These two are different angles. I'm going to have to calculate both of them. But once I figure them out, I don't have to calculate measure of angle 1 because the measure of angle 1 is the same as the measure of angle 8 because they are alternate exterior angles, and alternate exterior angles are congruent. So if I find the number for this, it's also there and I'm done, right? So that's what the book is asking us on 350, page 350. I know the transversal goes the other way, but it's the same deal, okay? So what are we going to do here? What in the world are we going to do? Well, we need to know if we have established a relationship between angle number 3 and angle number 8. Well, we don't have a regular relationship between the two of them. So what we're going to have to do is figure something else out. Okay. So 3 and 8. How are those related? Well, 7 and 3 are related because these things are congruent. And we've only got 2 measurements here. And again, we've got the obtuse and the acute. So here's what's going on. This one plus this one equals 180. Man, seems like they're going to do this to us again, right? So I've got 4x plus 6x equals 180. Combine my like terms. 10x equals 180. Now, why did I rewrite it? That's right, because I simplified my equation. And every single time that I simplify my equation, I rewrite it. We're going to put a separation between those things to keep our work separated on each side. But every single time I simplify something, I rewrite it so I don't have to keep it in my little head. So, one-step equation again. What can we do with a one-step equation? Yeah, everybody in the building knows how to solve this one. It's just a 10. There we go. Oh, 1. And 1x equals 18. That's right. Mark my answer like I always do. Now, what am I going to do with 18? Well, 4 times 18. 18 times 4, 2, 3, 72. So this one right here is a 72-degree angle. Now, 2 ways I can get to the other one. This is 6 times 18, or it's 180 minus 72. 180 minus 72 is 108 degrees. Or we could have done these 18 times 6, 8, 4, it's 108. Whoa! We must be right. So this is 108 degrees. And since that's 108 degrees, 108. Nice. Because alternate exterior angles are congruent. Now, I went through this very quickly. You have the freedom to take it back, watch it again, do whatever you need to do. We need to figure these out, though. These are the relationships that we're going to use. And if we keep track of what we're doing, geometry becomes a very simple issue. The idea is they ask you questions like, find these things, but you are the one that has to bring this knowledge into the problem. It doesn't say there was no equation here to start with. The equation came from us because we knew the relationships, and we had used prior to this, we had used informal arguments to establish facts about the angles that were created when a transversal cuts through 2 parallel lines. Thanks for watching. It's Halloween. Go eat some candy. Eat more than